trying to show that this is true. Knowing that this is just by definition, and that we have, as we seen in other video, z dagger being z minus z1 minus x1 x2 z z2 c. And we know also that this could be written just as a trace. Indeed, like, because if we check the definition, psi of AB by definition, it just, because it's an untoggled state at the beginning, it just 1 over the square root of t of the sum of t equal of g equals 0 to t minus 1 of gx or gb. And so it just means it's psi xz of AB, which by definition is just equal to xa x za z xor ib identity on b of psi ab. It just equal to 1 square root of t of sum of g equals 0 of t minus 1 of xa x z z of g a for gb. And so if you calculate the scalar products, you just give 1 over t of the sum of g k equals 0 to the minus 1 of g xa x1 za z1 dagger of xa x2 z za z2 of k xor gk of b. And so because it's orthonormous, you just have like delta gk, so there is only one term, and so we can put like this. ZA digger X, ZA. ZA digger X1, X2, Z2. And so we know, thanks to the definition, that just minus x1 and minus x2, and just a trace at the end. So we have the trace of z minus z1, x minus x1, x1, x2, z2. And so in the end, just like whenever d of the trace, we can, like, the trace is cyclic, so we can put like z minus of z2 minus z1, and of x of x2 minus x1. And or in the other sense. And so it's basically whenever d of the trace of delta x, x of delta x, and z of delta z, but like x of delta x, z of delta z, it just sum over k equal to 0 to the minus 1 of exponential 2pi of delta z k divided by d of delta x or k, because the definition of the operator x and z is just like here, same, because like we have z delta z of k being equal to exponential of 2pi delta z kd. And so if you just apply x, you just have delta x that it come into it across. So if you calculate the trace about this, you just find if like x1 is different to x2, trace is 0, and if x1 is equal to x2, we have the trace. And if z1 equals to 2, like delta z is equal to 0, and the other one is equal to the step. So if we retake our steps, we just have the bonding of z1 and z2. does the delta stuff, because it depends. We only have one term, so 1 over t, like we have like with sum over d, because this will be equal to 0, so just have d term multiplying by delta x1, x2, delta z1, z2, which at the end just gave delta x1, x2, delta z1, z2.